welcome back. In the diagram, M is the center of the circle, having Pn as its diameter. KL is a tangent to the circle at N. Right, for which values of K will y is equal to negative 4 over 3x plus K be a secant to the circle? Right now, we need to understand what a secant is. What is a secant? A secant is a line passing through 2 points in a circle. A secant is a line passing through 2 points in a circle. Unlike the tangent, a tangent is a line that touches the circle at what? At 1 point. Right? If we can have a secant, I can draw something like, let me use dotted lines, or let me just use this. This is a secant, okay, because it passes through 2 points of a circle. This is also a secant. See that? It's passing through 2 points in a circle. Right, now it says, for which values of K will y is equal to negative 4 over 3x plus K be a secant to the circle? We have to recognize that this line that we're talking about is parallel to the tangent, because we found that the equation of the tangent is y is equal to negative 4 over 3x plus 22 over 3. If this line has to be secant, it means it has to be between. Let me draw another tangent this side. Let's call it tangent 2. And then let's call this one tangent 1. If this line has to be a secant, it means it has to be between these two tangents. It has to be between tangent 1 and tangent 2. It has to be between tangent 1 and tangent 2. Otherwise, if it is below tangent 2, it's no longer a secant. It's no longer even a tangent. Okay. All right. If it's above tangent 1, it's no longer a tangent also. And it can be a secant. A secant has to be between these two tangents, where it is going to cut the circle at 2 points. Right. So now we can find the value of K. If we extend this, we know that, we try to extend this. Right. We know that the y coordinate of the y-intercept is going to be 22 over 3 from this, from the value of C there. 22 over 3, because this is 0, 22 over 3. Now we need to find the equation of tangent 2. We need to find the equation of tangent 2 and also find the y coordinates of its y-intercept. Right. Tangent 2 is the same gradient as tangent 1. The gradient has to be negative 4 over 3. We need to use the coordinates of P to find the equation of tangent 2. And then we have the coordinates of P here. Okay, remember we got this in question 4.1. Let's find the equation of our tangent 2. So it's going to be y is equal to negative 4 over 3x plus k. And then we substitute, y is negative 8. Negative 8 is equal to negative 4 over 3. Then x is negative 1 plus k. Right? Or you can see plus c is still fine. Let's find our k, or our c becomes negative 8 plus 4 over 3 is equal to k. Negative 8 plus 4 over 3 is negative 28 over 3 is equal to k. So meaning that the equation of tangent 2 should be y is equal to negative 4 over 3 x minus 28 over 3. Right, meaning that the y coordinate of the y-intercept is negative 28 over 3. Let me just write negative 28 over 3. We know that it's going to be 0. The x coordinate is 0. So it's going to be 0, negative 28 over 3. Right. And then now we're saying for this line to be a secant, it means the value of k should be between these 2 points. It should be below 22 over 3 or above negative 28 over 3. So we're talking about a line which is a gradient of negative 4 over 3. Could be here, could be there, could be there, could be somewhere there. Should be between these 2 points. But now it means the y coordinate of the y-intercept, which is k in this case, should be between negative 28 over 3 and 22 over 3. Negative 28 over 3 and 22 over 3 should not be included, because if you include them, the line will no longer be a secant but a tangent. When k is negative 28 over 3, the line is a tangent. When k is 22 over 3, the line is a tangent. But if k is between 22 over 3 and negative 28 over 3, the line is going to be a secant. Okay, so meaning that our k should be greater than negative 28 over 3, but less than 22 over 3. Okay, that's the solution there.